of quadrilaterals. So these do not have, they don't apply to any of the properties that we've been talking about with parallelograms. These have their own set of properties. They fall into a different category. So still a quadrilateral, still four sides. So trapezoid, quadrilateral, this just has one pair of parallel sides, just one. The parallelogram, the rectangle, the square, the rhombus, all those have both pairs of opposite sides parallel. If you're working with a trapezoid, just one pair. Okay, so what I'm going to do real quick here for you, I'm going to highlight this. And those are the two sides that are parallel. The two sides that are parallel, they call those a base. The other two sides that are not parallel, right? Here, I'm just going to lay my markers up. Like eventually, those two lines would intersect, right? They're not parallel to each other. If I extended those two sides, they're not parallel, they would intersect. However, both of those sides I can use as a transversal. So I want to just give you a little property here. I'm going to label these angles. I'm just going to say like 1, 2, 3, 4. If you know that you have parallel lines here, right? The top and bottom are parallel. What could you tell me about angles 1 and 2? They add up to 180, exactly. So here, angle 1 plus angle 2 would add up to 180. Okay, same question. I have parallel lines. What could you tell me about angles 2 and 3? I got parallel lines. What could you tell me about angles 2 and 3? Are they the same? What would you say about 2 and 3? Okay, that's okay, right? You immediately told me those would add up to 180. Why did you know that?
That's what we were talking about yesterday.
Okay. Do you know what kinds of angles those are? They are supplementary. I don't know if you guys remember this from first semester. Oh, excuse me. Those guys are called same side interior angles, which does mean they are supplementary. Okay, now, you literally have the same argument over here with angles 2 and 3. It's just, I'm still using these two parallel lines, like to form angle 2. I'm just going to use 3 lines here because I used 1 and 2 on the other. So I used 3 lines here. This angle is formed by the top and then that leg. Angle 3, I'm going to try to use 4 because I'm trying to show you they're not the same as the others. But those two angles are also a set of same side interior angles. Those would also add up to 180. So I got 2. Oh, I just wrote that wrong. That's probably why you guys were confused. I apologize. This was angle 1 and 4. All right, angle 2 and angle 3. The way I labeled it in my picture would also add up to 180. So if you're looking along one of the legs between the two bases, those angles have to add up to 180. Same thing, if I look between the two bases on the other leg, those two angles have to add up to 180. Now, you don't have any other, like 3 and 4 don't add up to 180 because these sides are not parallel. 1 and 2 do not add up to 180 because these sides are not parallel. So don't think anything of that, but these two would add up to 180, these two would add up to 180. All right, so if I gave you this, we got two parallel lines. You might want a calculator real quick here. These are parallel lines. Tell me the measure, like if I use this as a transversal, how would I find the measure of that angle in the bottom left corner? Like right here. What would this angle measure? 72. This and the 108 have to add up to 180. Okay, now, totally not involved with that. On these other sides, by the top and the bottom, the parallel lines, then I've got a transversal here. What would the measure of this angle be? 137. You just subtract it from 180. If you guys did want to check, do you know what the inside angles of any quadrilateral add up to? 360. So if you wanted to check real quick, we could do like 108 plus 72 plus 137 plus 43 should add up to 360. And actually, if you didn't want to use, if you found the 72 there, if you didn't want to use parallel lines, you could find that fourth angle by just knowing the inside angles add up to 360. So that's another option. But that's literally all you have to do. Is anybody having a question? This is just for general trapezoid. Now we had a couple special kinds, so we're going to talk about these again. mentioned them in our first lesson, but we're going to kind of focus a little bit more on their properties today. So one of the special cases is called an isosceles trapezoid. Isosceles trapezoid, a trapezoid, it's going to have two, I'm going to just use the congruent symbol, two congruent legs. So it still has to fit the property of a trapezoid that we got one pair of parallel sides, right? I'll come over in the diagram here. So they're just showing the top and bottom with the little arrow as being parallel. Okay, now the two legs then, if you look at the legs, different from the one I have above, the two legs on this trapezoid are marked as being congruent. That's that little single hash mark. So T to R and P to A, those segments are equal. If you have that, it does have a special property, and that's that the base angles of an isosceles trapezoid are going to be congruent. Okay, now it's actually two sets of angles, and you'll see it drawn here. But like on this diagram, angle T and angle P would be the same measure. And then also the other set of base angles would be angle R and angle A. Now, I know this is not written in here, but I'm going to remind you of something. Along the leg, like in that picture, angle T plus angle R has to add up to 180. So if I just look at like one side, those two have to add up to 180. Same thing on the other side. If you have angle P and angle A, those guys are same side interior. They have to add up to 180. But the major difference, if you have an isosceles triangle, the two angles at the top will be the same, and the two angles at the bottom will be the same. So, I only give you one angle here in this lovely trapezoid. I got a set of parallel lines. If it's an isosceles trapezoid, which this guy is, two sets of angles will be congruent to each other. So, if this is 65, tell me what other angle is 65? Up here?
No, F.
This one. Two at the bottom. These guys will be the same. Okay, now, can anybody tell me what angle D would be? Angle D or E, they're both the same.
115.
How'd you get 115?
Mental math.
Okay, is that right? I just want to check. My mental math's not that good. Your mental math is probably better than mine. Yes, okay, perfect. Now, these two guys are also a set of base angles at the top here. But between here, like 115 and 65, those both add up to 180. Those are same side interior. Same thing over here, but the two at the top and the two at the bottom will be the same. Okay, you guys tried this one. The lovely little parallel lines are kind of turned differently. So these are your two parallel lines that I'm highlighting on my paper. And these are your two congruent legs. So that's an isosceles trapezoid, two legs that are the same. See if you can label all the angles. There's three missing angles in that diagram. Don't forget your calculator. I need to use mine. What are the other three angles? Each one of them. You got Q, you got P, and you got S. What are the measures of each of those angles? Okay. Who can raise your hand? Tell me what'd you write for angle S? What'd you put?
For angle S, 106.
Excellent. What'd you put for angle P?
For angle P, 74.
Mm-hmm. And what about Q?
74.
Perfect. Is anybody having a question? All right, now, these, I know this is turned differently, but in this case, your same side, if I want to grab a different color here, like your same side interior, S and P, they're in between the parallel lines for the bases, and the transversal would be the legs, so those add up to 180. Same thing. I got these colors are too close together, forget. These guys, the 74 and 106, add up to 180. It's just kind of turned differently. Does anybody have a question? Okay, isosceles trapezoid also has another lovely property, which I just have at the bottom here. So it says if a quadrilateral is an isosceles trapezoid. So again, you got to have your parallel sides here, and you also have to have that the legs are marked as congruent. The two sides that are not parallel have to be congruent. If you have that, and now that first picture doesn't have them drawn in, but if you draw in the diagonals from A to C here in the diagram, and then from B to D here, those actually will be the same length. So the diagonals, they don't bisect each other, right? They don't cut each other in half. If you guys can see, like this little piece is shorter than this piece. So they don't bisect each other, but they are congruent to each other. So the lengths of those segments will be the same. Is anybody having a question? We'll do a little problem with that on the back. Okay. So I got an isosceles trapezoid here. And these are your two legs being marked the same. So that's how I'll know it's an isosceles trapezoid here. And it tells me TV, which is this diagonal here, is going to be 2x minus 1. These get tricky to draw in the diagram. U to S, which is the other diagonal, is x plus 2. So if this is an isosceles trapezoid, then the two diagonals TV and US are congruent to each other. So all you have to do is just set these two little expressions equal. So I'm going to do 2x minus 1 has to be equal to x plus 2. Can anybody walk me through how they would solve that equation? If I got 2x minus 1, x plus 2, what would you do to solve that? Oh, I heard like 3 different things. What do you want? Tell me what you want to do. Plus 1. Sure. All right, so I got 2x equals x plus 3. Then what do you want to do? Minus x. Hey, and that's not bad. 2x minus x is just 1x. We don't even have to divide anything. X would be 3. Now, if you needed to find the length of the diagonal, we could plug that back in. This guy, if I did 2 times 3, what would it be? 6 minus 1. So that diagonal would be 5. This should be the same. 3 plus 2. Also 5. They should have the same length. So if you want to check, just plug it back in. Make sure your diagonals have the same length. Okay. Now, this is not an isosceles trapezoid. This works for any trapezoid. There's one more special property that we have here. So you do have the two parallel sides. All right. And what they call a mid-segment. I'm going to write like a little note here because it doesn't say here. And you probably talked about mid-segments, but it was a long time ago. A mid-segment, I'm just going to write it underneath here. It's just going to be a segment that connects two midpoints. A mid-segment, all it is, it's a segment that connects two midpoints. So if you all are looking at the direction or the diagram here, so M is in the middle of this side from R to T, like the little marks being congruent. That's trying to show you M is the midpoint of that side. And then over here from A to P, N is the midpoint of that side. The markings here, these two are congruent, so they'd be the same on either side. So that's the midpoint. The mid-segment just connects those two midpoints. That's all you got going on there. And it has a lovely special property here. The mid-segment, first of all, is going to be parallel to the bases. So I'm just going to add another little arrow on that. All three of those lines will be parallel to each other. The length of the mid-segment is going to be half the sum, which means adding, the sum of the lengths of the bases. It's basically an average is what is going on here. So all three of these are parallel. MN is going to be parallel to RA, which is also going to be parallel to TP. So all three of those, both bases in that mid-segment, they're all going to be parallel. And this little formula, the mid-segment is going to be an average or half the sum of the other two bases. So the base, and it doesn't matter which one goes first or second, but whatever the length of RA would be, whatever the length of TP would be. If I add those together, cut it in half, it's just like taking an average. That's going to be the length of the mid-segment. So we're just going to find some missing segments here. All right. DG is your mid-segment in that lovely picture. The two bases of the trapezoid, the top and the bottom there, EF and CH. All you have to do, your mid-segment, where X is at, it's just half the sum of the bases. So I'm just going to take the top, and it doesn't matter which one goes first or second, and I'm going to take the bottom, we're going to add 8 and 20 and cut it in half. It's an average of the two. So it'd be half of 28, which means that mid-segment, half of 28 or 28 divided by 2 is just 14. Just an average. And that works for any trapezoid. It doesn't have to be isosceles. Okay. Now, a couple of these are a little trickier. So, my two bases in this trapezoid are going to be left side, right side. And my mid-segment is going to be in between the two. Okay. Can anybody tell me how they could set up a little equation here to solve for x? Because in this one, we're actually going to solve for one of the bases.
16x equals 22.
Close. Okay, I'm going to put the 22 here, right? That's the mid-segment. I'm going to put the 1/2, and then we're going to put the 16 and the x together. Would you multiply them, or would you add them?
Multiply them.
Is that what we're doing with there? You're going to add them. Okay. And it doesn't matter which one goes first or second. We're going to add them.
You gave me 2, so
I know. It was 50-50. Okay. Now, here's my best advice to you. Do we enjoy working with fractions? I don't. How can I get rid of a half? Like, without doing a distributive property, because I really don't want to mess around with that fraction. Is there a way we could get rid of a half?
you flip it,
What do you mean by you flip it?
like 2 over 1.
Exactly. And what do you do with the 2 over 1? You're right.
That's all I know. From there,
What did you say? You're going to multiply. Okay, if you want to get rid of a fraction, this is exactly, you're going to flip it over. I'm going to multiply both sides. It's really just 2. If you want to put it as 2 over 1. All it's going to do over here, 2 times a half becomes 1. So that just cancels that out. And you could just go ahead and then drop the parentheses. This would be 16 plus x. The other side, you actually have to multiply that by 2 to get rid of that 1/2. So this is just 44, but that's way easier to mess around with than the 1/2. So then I would just subtract 16 real quick. So 44 minus 16 is going to be 28, and that'll be the missing base there. If you want to plug it back in and check, 22 is supposed to be the average, right? So my two bases are now supposed to be 16 and 28. Add them up, cut it in half, 22, and that was the mid-segment. Okay, now, I'm not going to lie to you, this last one is really tricky because it's going to use variables, but I'm going to use the same setup. Okay. Across the top, across the bottom, those are the bases. So we're going to take an average of those two, and that should give me the mid-segment, which is here. Now, this is tricky because I've got a bunch of expressions. I do have one number. I have a plain 8, but the others are expressions. I'm literally just going to use this formula. So the mid-segment is in the middle of that lovely trapezoid. So the x plus 2, that's by itself. The mid-segment is an average, so I'm putting a 1/2 here, of the two bases added together. So the two bases, doesn't matter the order, one of them is 4x minus 10, and then the other base is 8. So I'm just plugging that information into that little formula. Okay, I'm going to do the exact same thing that we did on the other side in 1 second. Let me just do one thing first. I'm going to combine like terms on the inside of this here because I've got 4x minus 10 plus 8. I'm just going to add those numbers together. So negative 10 plus 8 would stay a negative number because the 10's a little bit bigger. So negative 2 there. Okay, do the exact same thing we did on the last question. Let's not mess around with the 1/2. We're not going to distribute. We're not going to do anything. We're going to multiply both sides by 2. Now, when you do that to the other side, because I've got an expression, we're not working with the 1/2, we're just working with a 2. Over here, what would I get if I take 2 times x plus 2? Like, what would that expression become? 2x plus 4. There you go. You got to give the 2 to both of those. Now, the other side, you just go, the 2 times the 1/2 cancels out. Just drop the parentheses, and you go ahead and keep that 4x minus 2. And then this is the equation we're solving instead of that original that we had set up there. So let me just do two things real quick. I'm going to subtract 2x. So I got 4 equals 2x minus 2. Sorry, I wrote too big here. I'm going to add 2. So 4 plus 2 is going to give you 6. Sorry, guys, I wrote too big. 6 equals 2x. And then we're just going to divide by 2 real quick. So x is going to be 3 for that question. That one was really tricky because of all the expressions, but it's all using that same formula. The mid-segment is an average of the two bases, or 1/2, add the two bases together. Is anybody having a question? Okay, we have a ton of